Hello everyone. So today we will discuss the projectile motion. Projectile motion is the motion when a particle is projected with an angle of theta from horizontal with the initial velocity u. Under the influence of gravity, it follow a parabolic path and then again fall back on the earth. This type of motion is called projectile motion. Now, for this type of motion, the initial velocity will be, this is initial velocity, this must be u is equal to u cos theta I cap plus u sin theta j cap. So this is responsible for horizontal motion and this is responsible for vertical motion. Both motions are independent to each other. They will not affect one another because they both have a 90-degree angle in between them. Now, time t is common for both motion. Common for both motion. That we will keep in mind. Suppose after time t, particle is at position x comma y. Suppose here it is the point where after time t the particle was found. Now, for horizontal, if you consider this horizontal part, x must be equal to u cos theta into t. Simple uniform motion equation I have used here because this is a uniform motion in horizontal direction. No acceleration is acting in the horizontal direction. But in case of vertical motion, it's a non-uniform motion. Acceleration due to gravity is always present in the system. Hence, we have to use the second equation of motion, that is s is equal to ut plus half at square. So what we will put here, if you put here s is replaced by y is equal to ut, u is the u sin theta, and t, since g is acting downwards, a negative sign will come, that minus half gt square. So this is equation number 1, this is equation number 2. Now if you will eliminate t from these two equations, you will get the trajectory of the projectile thrown from the initial point. So from first equation you will get t is equal to x by u cos of theta, and you put this value here in the second equation, you will get y is equal to u sin theta, this is first term, into t, that t is equal to x upon u cos of theta minus half g t square means x by u cos theta the whole square, and you see u and u goes away, and this implies that y is equal to x tan theta. First term will be like that, minus half, what is the other term? That is gx square divided by u square cos square theta. So this is equation of a parabola. So that's why I am told that when a projectile is thrown from the earth, it will follow always a parabolic path whose equation can be given by this relationship, where theta is the initial angle of projection and u is the initial velocity of projection. X and y are the coordinates of the particle at a given time t. Since I have eliminated t, this equation represents relation between x and y. So this equation represents the trajectory of the projectile. If we put y is equal to 0, means you will get 2 points. One point is here, x coordinate is here, means initial point, and the second coordinate of x will be the final point, and this x coordinate will represent what? Range R. So if you put y is equal to 0, you will get x tan theta minus half gx square divided by u square cos square theta is equal to 0. It has two roots of x. The first root will be x is equal to 0, because if you take x common, then it will become equal to 0. What is the second root? Second root will be gx divided by 2u square cos square theta minus tan of theta. This must be equal to 0. Hence, x is equal to tan theta will transpose here. You will get 2u square cos square theta tan of theta divided by g. So here sin theta by cos theta, 1 cos theta will cancel this square term. You will get 2u square sin theta cos theta divided by g, and this you will get u square sin 2 theta by g, and this second root of x is nothing but r. So range of projectile will be given by r is equal to u square sin 2 theta by g. This is the range part. Now we get trajectory as this equation and range as 2u square sin theta cos theta by g. If you divide range by horizontal velocity, which is constant, you will get time of flight. Time of flight. Time of flight means the time during which the projectile remains in the air. So it will be t is equal to nothing but r divided by u cos of theta, because u cos theta is the horizontal velocity with which the particle is traveling. And put the value of r here, you will get 2u square sin theta cos of theta divided by gu cos of theta. So cos theta will cancel away, u and u will cancel away. So time of flight will be 2u sin theta by g. This is your time of flight. Now when you put in this equation x is equal to r by 2, you will get the maximum height. So for h, put x is equal to r by 2. So what you will get? H is equal to x, put r by 2 means u square sin theta cos theta by g. This 2 will disappear from here because you are taking r by 2 into tan theta means sin theta by cos theta. This is first term, minus second term will be half g, and x square means r by 2 ka whole square means u power 4 sin square theta cos square theta by g square and divide by u square cos square theta. This term is already here. So this cos square theta, this cos square theta will cancel away. This u square will, this converts to u square. G will convert to this. So same term you will get, I think, cos theta cancel away means u square sin square theta by g. Here half u square sin square theta by g means capital H will be half u square sin square theta by g. This is maximum height. So you got all the 4 terms: projectile trajectory, range r, maximum range it will cover, time of flight, and maximum height. These 4 important parameters for projectile motion must be remembered to handle the problem of projectiles. If this information looks useful to you, please give a like button and please subscribe my channel. Thank you very much.